Okay, so yeah, thank you for staying around for our mini workshop on GNN tracking. So actually, let me try to minimize the Zoom thingy. Yeah, so I put together a few framing slides to kind of describe like what we're hoping to cover and accomplish with this workshop. We try to structure it a little bit differently than like a traditional conference because the goal is really to like foster discussion. No. So some quick motivation, as we've seen, GNNs are being used or applied very widely and have, we saw at least 7 talks. So possibly some others that I just looked at the titles when I was counting this. So possibly more than 7 just at this workshop about GNNs. We're doing dedicated sessions at big physics meetings, specifically on GNNs. They're a big focus of some of these kind of discussion and collaboration building events that have been happening recently, like Learning to Discover, which we heard a talk about, Hammers and Nails, similar kinds of like community building workshops. And, as we saw from talks here, they're being integrated with experiments. You got a hackathon in CMS, bringing tracking-based GNNs into the CMSSW. They're being integrated with things like ACTS. So, obviously there's a lot of attention on them. Similarly, in the broader space of machine learning, a lot of attention on geometric deep learning and GNNs in particular, because graphs and other kinds of geometric objects like manifolds and groups are really great for representing a lot of different types of data. Obviously, things that we work on with physical structure, but also anything that has some kind of relational information. And they're also nice because GNNs are these geometric models can incorporate a lot of different kinds of inductive biases, and they can encapsulate also a wide range of different kinds of models. So you can, get the same kind of like CNN operations, translation invariance out of a GNN. And there are different kinds of like model properties that you can extract from kind of treating GNNs as a base class. So it was a really interesting space that's happening. There's, dedicated workshops and tracks at things like NeurIPS, focused just on GNNs. There's a new graph focused conference that's happening this winter, I believe. There's, courses and textbooks and things. So it's a really exciting field. But how do we, ensure that this potential is realized, that it actually means anything for the kind of physics that we do? So that's kind of the motivation for why we put this workshop together. So we structured it around kind of 4 invited talks on different areas that we thought were relevant for kind of prompting discussion on like, we've shown we can apply these to different types of problems, but where do we go from there? How do we make it more meaningful and robust? So we have first a talk on accelerated inference. How do we make these models computationally efficient so that we can use them in experiments, particularly if we look at doing things like using them in the trigger. Interpretability, how do we validate these models, and can we then turn around and like use them to do new physics by trying to understand what the models are doing. Generative models, can we create synthetic geometric data? Can we do some kind of simulation speed up? We rely on simulation a lot in this field. And then finally, symmetries or equivariance. How can we bring kind of spatial or symmetric inductive biases into GNN? So we have these 4 invited talks, and then we have a nice set of contributing talks on kind of different like newer ideas or applications of GNN. So I don't know what happened over here. My lovely slides. So we have things on like hierarchical GNNs and heterogeneous GNNs. So how do we think about different kinds of data representations beyond just doing one kind of information on a node? GNNs in other types of experiments. We've heard about some LHC experiments. They're being utilized in other experiments as well, different task types focusing on specific types of particles, and then some more on accelerated inference. And we're really hoping that this is a like discussion and kind of thought building focused event today. So all of the talks are followed by longer than normal discussion time. So particularly the invited talks, we have like 15 minutes of discussion time after each one. So, you know, you can use this as a traditional opportunity to ask questions about the talk, but please like also, you know, feel free to just be like, oh, I've been thinking about, like, you reminded me, I've been thinking about this, like, has anyone else thought about this? Have you tried this? Like, it's not just questions about the talks, it's really meant to like share ideas. And then we have this workshop document that I'll show in a second that's open to all of the participants. So please spend a lot of time formatting it and stuff. So please, you know, please do contribute to it if you have, you know, things to say, and I'll show it in a second. And then just kind of to like prompt some of this discussion, some questions that at least I've been thinking about with GNNs in this context. And, you know, of course, there's many more, but these are some common themes that I've already seen coming out. So like, how do we facilitate research feasibility and consistency? We have lots of groups working just on tracking even, let alone all the other things that we can do with GNN. So how do we like create consistency across these different groups? How do we like share best practices, share knowledge? What are challenges that people are running into when using GNNs and HEP? How do we ensure this actually translates eventually into the experiments? And there's, you know, some work in this area already, but I think this is often a roadblock in like machine learning for HEP is you do lots of cool, fun things, and then do you ever use them, or do the experiments ever use them? And then what else can we do? There's you know, so much work happening in geometric deep learning in the broader machine learning space. We've already, you know, brought in some ideas like equivariance and these kind of things, but there's really so much more happening in that space. So are there ideas we can bring in to make this work even better? And then I put together this, you know, very short, very incomplete list, because I know there's like a range of backgrounds participating in this workshop. So if you were hoping for more of like an introduction to GNN, some codes, things like that, there's some resources here ranging from non-HEP focus at the top, so different kinds of overview talks, a really nice textbook by some of the big players in this space of college or a grad school class at Penn, and then some nice overviews of GNNs and particle physics, a tutorial that we did for the Fermilab LPC training on GNNs, some nice repositories that are intuitive and structured and documented well. So hopefully, yeah, if you're looking for that kind of stuff, I try to put together some resources here. And then real quickly before we go to our first talk, I will just show the doc. So you can see there's space for notes from the discussions after each of the talks. I'll try to like write down what I'm hearing, but please, you know, feel free to also add your own stuff. Then there's like some, it's so hard to scroll on this. There's some like other sections that I just put in there where, you know, if you're seeing a question that's coming up a lot, you know, note it down. If there's things you want to work on, and you're looking for someone to bounce ideas off of, or you need, you know, I don't know how to do this, does someone else know how to do this? You put it in here. And then, yay, people are doing it real time. So you can fill out some little information about you. It's kind of like those slides that we had for the general workshop, but specific to GNNs. And one of the ideas that I have here is in things like the Atlas ML group or IML or the CMS machine learning group, we're often like looking for people who work on GNNs, and you always, you know, have your friends who work on the same thing as you and you can bring up their names, but it's always better to have like a broader set of names. So if you're okay with, you know, sharing like, oh, these people are interested in GNNs, you can indicate that here, and we might eventually like share this with IML or something. So yeah, thank you very much for joining and participating. And yeah, I guess if there's any questions about the framing, happy to answer those. Otherwise, I will turn it over to Javier.